There are two general methods by which vectors may be added: graphical and analytical. The graphical method is further subdivided into parallelogram and polygon method. The analytical method of adding vectors is divided into two, using the laws of sines and cosines, and the component method. In vector operations, the laws of sines and cosines are generally used if there are only two vectors to be added. The component method is more convenient to use than the laws of sines and cosines if there are more than two vectors to be added. To determine the resultant of two vectors under parallelogram method, first, using suitable scale, draw the arrows representing the vectors from a common point. Second, construct a parallelogram using the vectors as two sides. Third, draw the diagonal of the parallelogram from the common point. This represents the resultant R. Fourth step is to measure the length of the arrow representing the resultant, and from the scale used, determine its magnitude. And lastly, determine the direction of the resultant vector using a protractor. For our first example, two forces A and B are acting on an object. Force A is 3 Newton directed north, and force B is 4 Newton 30 degrees north of east. Find the resultant force acting on the object using the parallelogram method. Using the scale of half of a centimeter is to 1 Newton, the parallelogram using forces A and B as side is drawn as shown in the figure. Using a protractor, the angle theta the resultant makes with horizontal is approximately 55 degrees. Therefore, R is 6 Newton, 55 degrees north of east. For our next example, a particle is being acted upon by the following forces. F sub 1 is 4 Newton east, force sub 2 is equal to 6 Newton northeast, and force sub 3 is equal to 8 Newton south. Find the resultant using the parallelogram method. You may add the forces according to the following grouping: sum of F1 plus F2 plus F3. As shown in the figure, R1 is equal to 4 sub 1 plus 4 sub 2, while R sub 2 is equal to R sub 1 plus F sub 3. Thus, the resultant is 9 Newton, 25 degrees south of east using the scale of 1 centimeter is to 1 Newton. For our last example, using the same forces in previous example, find 4 sub 1 plus the sum of 4 sub 2 plus 4 sub 3. Compare your answer with the resultant obtained in previous example. As shown in the figure, R sub 1 is equal to 4 sub 2 plus 4 sub 3, while R sub 2 is equal to R sub 1 plus 4 sub 1. The resultant vectors are the same, 9 Newton, 25 degrees south of east. This is an application of associative property of vectors. Next, we have the polygon method, or also known as the tip-to-tail method. This method is used whenever we are adding two vectors under graphical method. And to determine the resultant, first, represent each vector quantity by an arrow drawn to scale. Second, starting from the origin, draw the first vector on the rectangular coordinate system, accounting properly its direction. Third, connect the tail of the second vector to the head of the first vector. Connect the tail of the third vector to the head of the second vector. You may continue drawing the vectors head to tail until you draw the last vector to be added. Fourth, the resultant will close the figure formed by connecting the vectors. This resultant is drawn from the tail of the first vector to the head of the last vector. Fifth, measure the length of the arrow representing the resultant. Determine the magnitude of the resultant from the scale used. And last, use a protractor to determine the direction of the resultant. For our first example, you are out for an early morning walk 5 meters south and 12 meters east. Then, you decided to walk farther and go 4 meters southwest and 6 meters west. How far are you now from your starting point and in what direction? Would you have arrived at the same spot had you taken the steps in this order? 12 meters east, 4 meters southwest, 5 meters south, and 6 meters west. Use the polygon method to determine your answer. To answer problem A, let vector A be equal to 5 meters south, vector B be equal to 12 meters east, vector C be equal to 4 meters southwest, and vector D be equal to 6 meters west. Figure shows that the polygon formed by adding the displacements in the order of vector A plus vector B plus vector C plus vector D is equal to the resultant, that is approximately 8 meters with the direction of 68 degrees south of east. To solve for problem B, the displacements are added in the order of vector B plus vector C plus vector A plus vector D. Changing the order of adding displacements does not affect the resultant. This is the consequence of commutativity of vectors when added together. From the scale used, 1 meter is to 1 centimeter, the resultant is approximately 8 meters, and its direction are approximately 68 degrees south of east. When we are adding two vectors, observe that it forms a triangle, and to solve a triangle is to find the lengths of each of its sides and all its angles. During your pre-calculus course under trigonometry, the loss of sine is used when we are given either two angles and one side, or two sides and a non-included angle. The loss of cosine is used when we are given either three sides or two sides and the included angle. To further understand, we have our first example. Two forces A and B are acting on a particle at O. Force A is 3 Newton directed north, and force B is 4 Newton 30 degrees north of east. Find the resultant force using the laws of sines and cosines. To solve this problem, we have force A directed north and force B 30 degrees north of east. An included angle of 120 degrees obtained from adding 90 degrees and 30 degrees. From the figure, the angle opposite to the resultant is 120 degrees. Using the laws of cosine, we have r squared is equal to a squared plus b squared minus 2ab cosine 120 degrees. Substituting the values, we have r squared is equal to 3 Newton squared plus 4 Newton squared minus 2 times 3 Newton 4 Newton cosine 120 degrees. Getting the roots of both sides, then we obtained r, which is equal to 6 and 800 of Newton. And now to determine the direction of the resultant, we use the law of sines and solve for the angle of AOR or phi. We have 4 Newton over sine phi is equal to 6 and 800 Newton over sine 120 degrees. Multiplying both sides by sine phi times sine 120 degrees over 6 and 800 Newton times 4 Newton over sine phi is equal to 6 and 800 Newton over sine 120 degrees, we obtained 4 Newton times sine 120 degrees over 6 and 800 Newton is equal to sine phi. Performing the indicated operation, we obtain an approximate value for sine phi. In getting the inverse value of sine phi, we have 34 and 7200 degrees. Note that phi, which is equal to 34 and 7200 degree, is with respect to north direction. The angle theta that the resultant makes with the east direction is equal to 90 degrees minus 34 and 7200 degrees, which is equal to 55 and 2900 degrees. Thus, the magnitude and direction of the resultant is 6 and 800 Newton, 55 and 2900 degrees north of east. For our next example, we have displacement vector A is 4.5 kilometers north, whereas the displacement vector B is 3 kilometers 50 degrees north of west. Find the resultant displacement using the laws of sines and cosines. From the figure, the angle theta opposite the resultant is 140 degrees. Using the laws of cosines, we have r squared, which is equal to a squared plus b squared minus 2ab cos theta. Substituting the given values, we have r squared, which is equal to 4.5 kilometers squared plus 3 kilometers squared minus 2 times 4.5 kilometers times 3 kilometers cosine 140 degrees. Getting the roots of both sides, then we have resultant, which is equal to 7 and 700 kilometers. We now determine the direction of the resultant vector using law of sine. We have 3 kilometers over sine phi is equal to 7 and 700 kilometer over sine 140 degrees. Multiplying both sides by sine phi times sine 140 degrees over 7 and 700 kilometer, we obtained 3 kilometers times sine 140 degrees over 7 and 700 kilometer, which is equal to sine phi. Performing the indicated operations, we obtain an approximate value for sine phi. In getting its inverse value, we have phi, which is equal to 15 and 8400 degrees. Note that phi, which is equal to 15 and 8400 degree, is with respect to north direction, the angle that the resultant makes with the east direction. So, 90 degrees is equal to 15 and 8400 degree, which is equal to 74 and 1600 degree. Thus, the magnitude and the direction of the resultant is 7 and 700 kilometer, 74 and 1600 degree north of west. The component method is generally used when more than two vectors are to be added. The steps involved in adding vectors using the component method are as follows. First, resolve the given vectors into its horizontal and vertical components. To do so, we have horizontal or x component is equal to vector in x is equal to magnitude times cosine theta or its direction. While in vertical or y component, we have vector in y is equal to magnitude times sine theta or direction. To determine the appropriate sign of horizontal and vertical components of the given vector, we should follow different quadrants of the Cartesian coordinate system where the vector lies. First, we have in quadrant 1, all functions are positive. In second quadrant, sine and its reciprocal are the only positive function. In third quadrant, tangent and its reciprocal are the only positive functions. And lastly, cosine and its reciprocal are the only positive function in quadrant 4. For the second step, get the algebraic sum of all the horizontal components or summation of vector in x. Also get the algebraic sum of all the vertical components or the summation of vector in y. These sums represent the horizontal component and the vertical components of the resultant respectively. When we are considering the direction of the obtained resultant, we should only have to look at the direction of the horizontal and vertical components, and that will lead us to its direction. Since the vertical and horizontal components are perpendicular to each other, the magnitude of the resultant may be calculated using the Pythagorean theorem. We have square root of r is equal to summation of v sub x squared plus summation of v sub y squared. And lastly, to solve for the angle theta that resultant makes with the horizontal, we have theta is equal to arctan or inverse tan times the absolute value of the summation of v sub y over summation of v sub x. Note that the summation of v sub y over summation of v sub x means the absolute value of the sum of the vectors along the y-axis divided by the sum of the vectors along the x-axis. For example, Anna runs 4 meters 40 degrees north of east, 2 meters east, 5.2 meters 30 degrees south of west, and 6.5 meters south before stopping for water break. Find her resultant displacement from where she started. To solve this problem, first we will follow the first and second step, which is tabulate the horizontal and vertical components of vector and get its vector sum. We have, for vector A, we have 4 meters 40 degrees north of east. Note that its direction lies on first quadrant. So to determine its first horizontal component, we have 4 meters cosine 40 degrees, and that yields to 3 and 600 meters. To determine its vertical component, we have 4 meters sine 40 degrees, and that yields to 2 and 5700 meters. To solve for B vector, we have 2 meters east. Since east only lies in horizontal, so we only have a value for horizontal component, while in vertical component, we have no value. And it follows that our horizontal component for B vector is 2 meters. For vector C, we have 5.2 meters, 30 degrees south of west. Note that the indicated direction lies on third quadrant, where tangent is the only positive function. Therefore, sine and cosine are both negative. For the horizontal component, we have negative 5.2 meters cosine 30 degrees, and that is 4.5 meters. For vertical component, we have negative 5.2 meters sine 40 degrees, and that yields to negative 2.6 meters. For vector D, we have 6.5 meters south. Note that south only lies on vertical. So therefore, we don't have value for horizontal component, while our vertical component has 6.5 meters negative because the direction is downward. So therefore, we have d sub y, which is equal to negative 6.5 meters. Getting the sum of the horizontal component, we have summation of d sub x is equal to 0 and 5600 meters, while the sum of the vertical component is equal to negative 6 and 5300 meters. Next, solving for the magnitude t sub r of the resultant, we now follow the third step and use the Pythagorean theorem. We have the square root of t sub r is equal to the square root of the summation of t sub x squared plus the summation of t sub y squared. Substituting the values, we have square root of 0 and 5600 meters squared plus negative 6 and 5300 meters squared, and that yields to 6 and 5500 meters. Solving for the direction theta of the resultant, we follow the fourth step. Theta is equal to arctan summation of d sub y over summation of d sub x, which is equal to arctan summation of negative 6 and 5300 meters over 0 and 5600 meters, and that is equal to 85 and 100 degrees. Since summation of d sub x is positive and summation of d sub y is negative, the resultant must be in fourth quadrant. Hence, the direction must be 85 and 100 south of east. Therefore, the magnitude and direction of the resultant is 6 and 5500 meters, 85 and 100 south of east. For our last example, find the resultant of the following forces by component method. Force sub 1, which is equal to 12 Newton south. Force sub 2, which is equal to 24 Newton 30 degrees south of west. Force sub 3, which is equal to 15 Newton 75 degrees south of west. And force sub 4, which is equal to 32 Newton 50 degrees south of east. To solve this problem, first, we will follow the first step and second step, which is tabulate the horizontal and vertical components of each vector and get its vector sum. We have, for first vector, force sub 1, which is equal to 12 Newton south. The direction is indicated for south or downward direction for vertical. So therefore, horizontal component has no value. And for vertical component, we have negative 12 Newton. For force sub 2, we have 24 Newton 30 degrees north of west. The direction is in quadrant 2, wherein the positive function is sine. So therefore, for our horizontal component, we have negative 24 Newton cosine 30 degrees, which is equal to negative 20 and 7900 Newton. While for vertical component, we have 24 newtons sine 30 degrees, which is equal to 12 newton. For our third vector, which is our force of 3, 15 newtons 75 degrees south of west, the direction can be obtained or determined at the third quadrant, wherein the only positive function is tangent, meaning cosine and sine are both negative. For horizontal component, we have negative 15 newton cosine 75 degrees, which is equal to negative 3 and 8800 newton. And for force of 3 in vertical component, we have negative 15 newton sine 75 degrees, which yields to negative 14 and 4900 newton. And lastly, for our fourth vector, which is force of 4, which is equal to 32 newton 50 degrees south of east, where the direction is lying at the fourth quadrant, where the only positive function is cosine. So therefore, the horizontal component follows that 32 newton cosine 50 degrees, which is equal to 20 and 5700 newton. And for the vertical component, we have negative 32 newton sine 50 degrees, which is equal to negative 24 and 5100 newton. Getting the sum of the horizontal component, we have the summation of force of x is equal to negative 4.10 newton. And for our vertical component, its sum is negative 39 newton. And to solve for the magnitude f sub r of the resultant, we follow the third step using Pythagorean theorem. We have square root of f sub r, which is equal to the square root of the summation of f sub x squared plus the summation of f sub y squared, which is equal to the square root of negative 4.10 newton squared plus negative 39 newton squared, which is equal to 39 and 2200 newton. To solve for the direction of the resultant, theta, we have theta is equal to arctan times the absolute value of the summation of f sub y over the summation of f sub x, which is equal to arctan, the absolute value of negative 39 newton over negative 4.10 newton, which is equal to 84 degrees. Since the summation of f sub x and the summation of f sub y are both negative, the resultant must be in the third quadrant. Hence, the direction must be 84 degrees south of west. Therefore, f sub r is 39 and 2200 newton, 84 degrees south of west. To further assess your learning in this topic, you can visit your Google Classroom. Kindly open the folder with name Check Your Understanding. There will be 2 sets of exercises, the multiple choice and problem solving.
Thank you very much for watching. We hope that you learned. See you on our next topic. Bye!